In propositional logic, there are two types of sentences: simple sentences and compound sentences. Simple sentences express simple facts about the world. Compound sentences express logical relationships between the simpler sentences of which they are composed. In propositional logic, simple sentences take the form of atomic symbols called proposition constants. By convention, we write proposition constants as strings of letters, digits, and occurrences of the underscore character. In order to avoid conflict with other types of symbols we use later, we require that every proposition constant begin with a lowercase letter. For example, raining, spelled as shown here, is a proposition constant, as are raining, spelled with lower and uppercase letters, but beginning with a lowercase letter, are 32 raining, and raining underscore or underscore snowing. Raining beginning with a capital letter is not a proposition because it begins with an uppercase letter. 3, 2, 4, 5, 6, 7 is not a proposition constant because it begins with a number. Raining hyphen or hyphen snowing fails because it contains the dash or minus dash character or minus sign. Compound sentences are formed from simpler sentences and logical operators of various sorts. There are 6 types of compound sentences in propositional logic. A negation consists of the negation operator followed by a simple or compound sentence, all enclosed in parentheses. For example, given the sentence P, we can form the negation of P as shown here. The argument of a negation is often called the target of the negation. A conjunction is a sequence of sentences separated by occurrences of the AND operator and enclosed in parentheses. For example, we can form the conjunction of P and Q as shown here in the middle. The AND operator is usually written using this wedge-like symbol, though occasionally we use ampersand, for example in typing formulas for application programs. The constituent sentences of a conjunction are called conjuncts. A disjunction is a sequence of sentences separated by occurrences of the OR operator and enclosed in parentheses. For example, we can form the disjunction of P and Q as shown in the example at the bottom. The OR operator is usually written using this upside-down V, though we sometimes use vertical bar as an alternative, again when we're typing for application programs. The constituent sentences in a disjunction are called disjuncts. 3 down, 3 to go. An implication consists of a pair of sentences separated by the implication operator and enclosed in parentheses. The sentence to the left of the operator is called the antecedent, and the sentence to the right is called the consequent. The implication of P and Q is shown here in the example at the top. A reduction is the reverse of an implication. It consists of a pair of sentences separated by the reduction operator and enclosed in parentheses. In this case, the sentence to the left is called the consequent, and the sentence to the right is called the antecedent. An equivalence, or biconditional, is a combination of an implication and a reduction, and we can express it as shown here at the bottom. Note the constituent sentences with any compound sentence can be either simple sentences or compound sentences, or a mixture of the two. For example, the expressions here are all legal compound sentences. One disadvantage of our notation, at least as written, is that the parentheses tend to build up and need to be matched correctly. It would be nice if we could dispense with unnecessary parentheses, as shown in the example at the middle. Unfortunately, we can't do without parentheses entirely, since then we would be unable to render certain sentences unambiguously. For example, the two different sentences shown here would result in the same unparenthesized expression, even though they mean different things. The solution to this problem is the use of operator precedence. The table shown here gives a hierarchy of precedence for our operators. The negation operator has higher precedence than any of the other operators, and has higher precedence than OR and the remaining operators, and OR has higher precedence than the implication operator, the reduction operator, or the equivalence operator. And those last 3 operators have equal precedence. In unparenthesized sentences, it's often the case that an expression is flanked by operators, one on either side. In interpreting such sentences, the question is whether the operator associates with the operator whether the expression associates with the operator to its left or to its right. We can use precedents to make this determination. In particular, we agree that an operand in such a situation always associates with the operator of higher precedence. When an operand is surrounded by operators of equal precedence, the operand associates to the right by convention. The examples here show how these rules work in various cases. Expressions on the right are the fully parenthesized versions of the expressions on the left. In the first case, Q in the middle is associated with the and because and has higher precedence than or. Similarly, in the second sentence, Q is associated with the and on the right side, since again, and has higher precedence than or. In the next two cases, the association is to the right because the operators are of equal precedence. And then the final example, P is associated with not because it's the operator with the highest precedence of all. That's all for syntax. Let me just summarize with a few definitions. We use the phrase propositional vocabulary to refer to a set or sequence of propositional constants. Given a propositional vocabulary, a propositional sentence is either an individual member of this propositional vocabulary, or it's a compound sentence formed from simpler sentences built from this vocabulary. Finally, a propositional language is the set of all propositional sentences that can be formed from a propositional vocabulary. This exercise tests your grasp of the rules of syntax by asking you to determine whether various expressions are syntactically legal sentences in propositional logic.